All right. So, solving systems. Again, there's 3 ways you've done it up until now. Kind of 4 if you want to count guess and check in there. Okay? But you've been taught substitution, which is when you get either x or y by itself and then plug that formula in for the variable in the other equation. There is graphing. If they were both in the y equals, these are lines, so y equals mx plus b, you could graph, see where they cross over each other. Or elimination, and that's where you stack your x's and your y's and your constants on each other. You try to eliminate something, so you could like multiply one of the equations by something. I personally did elimination for these problems. Okay, so let me show you what I did. That's okay. Okay. Again, it's been a hot minute since you've done them. So for part A, I multiplied just the top equation by 3 because then I have my y's as a -3 and a +3, which is 0. They are eliminated. I solved for my x, plugged it into one of the originals, and I got my y. I'm going to zoom in from part A for y'all. Okay, so if I were to actually graph these lines would cross over at the point 4, 2, is what that is saying. Right, so your goal is to get, if you're doing elimination, you have the same coefficient, but one's positive and one's negative. So when they add up, they give you a 0. Right? And then part B, there's a couple of ways to do it. I noticed that my top x was negative and my bottom x was positive. So I multiplied the top equation by 3 again in part B. I'll give you all a second before I slide this over. All right, slide over. So for part B, I would also multiply the top by 3. This time your x's get eliminated. You can solve for your y. Plug that into either one. I chose the bottom one, and I got an x value of 1. So these 2 lines would cross over at the point 1, -6. Okay. So what we're going to do today is add another method of solving, and it's called the matrix method. Yay! Yes. We're going to do Cramer's rule today, which is another method of solving systems. And so like if we had 3 variables and 3 equations, like an x, y, z, matrices is usually when we bring that out to help solve for each of those. There's a couple of ways to solve, so we're going to do one way today, Cramer's rule, and I'll show you a different way to do it on Monday. I know, I'm not going to see you all till Monday.
Oh, yeah.
It's like 5 days.
That's a long time.
I know.
How are you going to live?
Wait, so May
Not.
22nd is the last day of school, right?
May, for us, yes. For us, May 22nd is our last day. I lied. Your second period. There we go.
It's the first
You're the last exam.
So we have to be here.
Again. Uh-huh.
I don't know.
The exam matters. Yes, you got to be here. The exam is important.
No, let's do it on Monday.
All right, so today we are going to learn how to solve. But before you can jump into solving, there is something called a determinant that we need to figure out how to do with matrices, okay? Associated with each square matrix. What's a square matrix? When your rows and your columns are the exact same thing, 2 by 2, 3 by 3, 4 by 4, whatever, okay? Is a real number called its determinant. Okay. The determinant of a square matrix A is denoted 2 different ways. You might see it with D, E, T, and then A, like that. Or by what you think are absolute value bars. Okay? So that's why I told you the hooks mattered. Because if you had just straight bars, it was something else. It's this. Okay? Straight bars is indicating to find the determinant of the matrix. Okay, so there's a couple of ways to show how to find it. Okay, it's possible with any square matrix. We're going to stick with 2 by 2s and 3 by 3s. All right. We good? Obviously, we're going to do a 2 by 2 first. Okay. So looking up here, if I have a 2 by 2 matrix, A, B, C, and D, what you do is you multiply A times D, that's that downward diagonal, and you subtract from it your upward diagonal, which is going to be C times B, okay? You always subtract them. So if C times B is a negative number, you will add because you'll be subtracting a negative, okay? So watch out for that. It's little things that get you guys sometimes. Okay? So let's find the determinant of 2, 5, 1, and 4, okay? My downward diagonal is these two, right? We have 2 times 4, which is 8. There we go. I know. It's like... And now my upward diagonal. We have 1 times 5, which is... There we go. So our determinant, I will call this A because it's example A. Our determinant of matrix A is 3. It will just be a nice little number like that. Okay, it'll be real numbers. It could be positive. It can be negative. Okay, technically it could be decimals or fractions if that's what's built into the matrix. It's very possible. Okay, there's one thing that we don't want it to be. What do you think? Which one? What number do you think might be an issue later? 0? Maybe? Zeros are usually issues for some things, right? So just keep that in mind. Okay? They're allowed to be positive and negative. Okay? 0 will be an issue, and we'll talk about why it's going to be an issue. All right? Now, time for 3 by 3s. We got this guy. Okay? I know. Stay with me. I know. It is a lot of lines. But we're about to find the area of a triangle, actually. Speaking of geometry. I know. So this time we do the same thing. We have our downward diagonals, which is the blue. We multiply, add all those together. Then we have our upward diagonals, the red. Multiply, add all those together. And then you subtract. Okay? Now, I need 3 things to multiply together when I do this. So if you'll notice, the first 2 columns get rewritten at the end. See the ADG and BEH? It got rewritten again, okay? And that has to happen. So you have to rewrite. So for this one, 3, 2, negative 2, 4, 0, negative 3. So you rewrite the first 2 columns. Okay? Because it's a 3 by 3, we should be multiplying 3 things together. All right. Here we go. We're going to work our way down first. Okay? So my first diagonal is 3 times 0 times 1. What does that give us? 0. Okay. Then, so we're going to add all these together. What is 4 times 6 times negative 2? Negative 48. Good. And then negative 1 times 2 times negative 3. Positive 6. Good. So what is 0 plus negative 48 plus 6? Negative 42. Bless you. Okay. So we multiplied the diagonals down. We added those pieces. All the downs got added together. Okay. So this is one side. All right. Now let's do our upward diagonals. So start in the bottom corner and diagonal up. Negative 2 times 0 times negative 1. 0. It's always nice when there's a 0 in there. Makes it a little bit easier. All right, next, negative 3 times 6 times 3. What? Negative 54. And then 1 times 2 times 4. 8. Okay, so my upwards are 0, negative 54, and 8. Add those together, and what do we get? Negative 46. So my downs minus my ups gives me a determinant of what? A determinant of 4. I'm going to call this matrix B just because it's example B. Is that okay? So my determinant, I'm going to switch my notation too. Boom, the determinant of B equals 4. So that's the same notation as the one from before. They mean the same thing. All right? What's that? Does it matter which one you use? Oh, the notation? No, they're the same thing. Mm-hmm. Yep, I don't care. So we can also use this to find the area of a triangle. Okay, we're going to use the vertices from a coordinate plane as our x1, x2, x3, y1, y2, y3. Okay, and our third column is going to be a 1. Okay, because with determinants they have to be a 3 by 3, right, or a 2 by 2. Okay, so I'm adding in a column of 1 because if you think about it, we're multiplying, right, adding things together. If I'm multiplying by 1, I'm not changing anything. Right? So that's why we add a column of 1 in there. So now it's a square that haven't altered the data, and we can find the determinant of this. So we find the determinant of it, and then we multiply by positive or negative 1/2. Okay? It says it indicates that the appropriate sign should be chosen to yield a positive value. What does that mean? Why? Why does my answer have to be positive? Because what?
You can't have negative sigma.
You can't have negative what?
Side.
Side links? Okay. Is that what you were saying? And in total, we're finding area. So we can't have negative area either. Okay, so that's why. What's up, Noah?
Does it have to be a right triangle?
No. Nope, it could be any triangle. Yep. So in geometry, you'd have to what? Use the distance formula, right? To do this, and then like do something with the base and the height. I don't remember because I haven't done that in a hot minute. What was it, like half base height? Maybe? I don't know. Anyway, we, instead of doing all that, are going to use a matrix to help find the area. Okay? So the area of this guy is going to be positive or negative 1/2. We're not sure which one. Whichever one gives me a positive answer, right? Our determinant is going to be my 3 vertices. It does not matter what order you put them in. I'm just going to start from the top and work my way down. So I'm going to say 2, 3. Then I have the vertice 3, negative 2. And then the vertice negative 4, negative 3. And we put in a column of 1. Okay. We will find the determinant first and then do 1/2 of that value. So the 1/2 will be last. So to find the determinant, I have to rewrite the first 2 columns. That looks like 23. There we go. 3, negative 2, negative 4, negative 3. All right, let's do the downward diagonals first. What are my downward ones? Blue? Yes. Okay. So what is 2 times negative 2 times 1? Okay. 3 times 1 times negative 4. 1 times 3 times negative 3. Negative 9. So this is negative 4 plus negative 12 plus negative 9, which gives us what? Negative 25. Okay. Now let's do our upward diagonals. So -4 times -2 times 1. 8. Okay. -3 times 1 times 2. -6. 1 times 3 times 3. 9. So 8 plus -6 plus 9 gives us what? I think it's just 11, right? Okay. Oh, you go on. Bless you. So what is -25 minus 11? -36. So this is our determinant. So we're going to do 1/2 positive or negative times the determinant of -36. And that gives me, we're going to always keep the positive. We're going to make it 18. So the area of the triangle is 18 square units. They didn't tell me what it was. So okay. Yeah, nope. We just use the vertices. No side links needed. All right, so why are we finding determinants? Because we need them to solve a system. Okay? Yep. So if you're given two things like your warm-up, we're only going to worry about the coefficients and the constants. We good? We flipped over? All right. So, to solve, okay, there's a couple of methods. The method we're doing today that using our determinants to solve a system of linear equations is called Cramer's rule. All right, and it is named after a Swiss mathematician, Gabriel Cramer. And it uses the coefficient matrix. Okay, so we have a 2x2 and we have a 3x3. So if you are given a 2x2 system, so we have 3x minus 2y equals 7, and we have 5x plus 4y equals -3. Okay, the first thing we always do is find the determinant of the coefficient matrix. Okay, because if my determinant is 0, we can't move forward. Because if you look at how to find x and y, we divide by the determinant. So if our determinant is 0, we can't do that. We would have no solution. Which means, what about my lines? So if they don't have a solution, what are they? Well, so that means they're what? Yeah, they're parallel lines. I know. Fancy. Okay. So notice also, when I am solving for x, okay, my variables a, c get replaced with our constant matrix EF. Okay, when you're solving for y, your y column gets replaced by the constant column. So what you're searching for is no longer in your matrix. You replace it with your constants. Okay, let's do it so it makes sense. Okay. First off, the determinant of our coefficient matrix. So our coefficient matrix is 3, 5. That's my coefficients for my x. And then my y's have a coefficient of -2 and 4. Okay. We like 2x2s, right? So this one gets set up as 12 minus -10. Does that make sense where that just came from? Yeah, that's 3 times 4. This was 5 times -2. And what is 12 minus -10? Positive 22. All right, so does this have a solution? Yes, it does. Okay, so now let's use our x and our y formulas to find what is missing. Okay, so it says to find my variable x, I need the determinant of, here's my solutions, and here's my y's, divided by the determinant we just found. So if you're looking for x, that column gets replaced by my constants. So we need a determinant for the 7, -2, -3, and 4. So we're going to multiply 7 times 4 to get 28. -3 times 2 is +6. So 22 over 22 gives us a 1. So we have an x value of 1. Let's do it now to find our y. Okay, so y, this time we're going to use the x values, right? We have 3 and 5. I did not leave enough space. All right, so now our x's are 3 and 5, and our constants are 7 and -3. We're going to find that determinant and divide it by 22. So 3 times -3 is -9, minus 5 times 7, which is 35. -9 minus 35 is going to give us -44. Over 22 gives us -2. So the solution is going to be 1, -2. I heard someone say they couldn't see it.
Wait, you said,
Okay,
you said if the determinant 0, there's no solution.
correct. Because see how we're dividing by 22? So if that was a 0, we couldn't divide by 0. And that's what would make it no solution. If you have parallel lines. It just depends on what the system is. Because Cramer's rule for a 3 by 3 is a whole lot of determinants of 3 by 3s, right? And we just figured out on the front, that's a lot of work. Do you think our calculators can do that part for us? Yes, your calculators can find the determinants, okay? If you ever have a determinant of a 2 by 2, show your work. It's not that bad, right? We can do that. If I'm asking you for the determinant of a 3 by 3, you can absolutely use your calculator. Okay? Especially with Cramer's rule, when technically we're going to have to find 4 different determinants of 3 by 3s. That's a lot. Okay? So, we have a 3 by 3, meaning I have 3 equations with 3 variables this time, x, y, z. Okay? And then I have a constant of 21, -5, and -17. So, before we do anything, we have to make sure that we can do the problem. So, let's find the determinant of our coefficient matrix. Okay? So, our coefficient matrix is, my x's have coefficients of -1, +1, +1, and -3, 4, -2 for my y's, and my z's have coefficients of 5, -3, and -1. Okay? So this is the matrix you're going to put into your calculator. Okay? This is the matrix you're going to put into your calculator. So I'm going to pull that up on my screen. Okay? Where is this one? Bless you. And we did find the matrix calculator on Desmos, by the way. If you go to their website and go to Math Tools, it drops down, and a matrix calculator is an option. So it does exist in Desmos. Okay, so you ready to remember how to do it? Learn how to do it?
Yes.
Get you a calculator. You're going to want this, especially for your quiz, because then you can use it on your quiz too. So it's going to save you just a lot of time. Yeah, so our matrix button is the inverse button. So we're going to push second and then that X to the -1 to get to our matrix menu. You can just write on top of it if you want to. Or you can, if it's one of my calculators, you can just do the reset, the second plus 712, and it'll get rid of everything if you want to do that. Yep. Okay, so we're going to go over to edit. Okay, so second. These are the buttons I'm pushing. For you, you'll do. Yeah. Second, alright, go over to edit. Click matrix A. We are making ourselves a 3x3, so we tell it it's a 3x3. And then we fill it in with our coefficient matrix. 5. My next row is 1. Remember to push enter after each time you put something in, especially the last one. -2, -1. So make sure it looks like our coefficient matrix. So second matrix, forward to edit. Enter. And make it a 3x3. And then put in those values. Okay, so once you got this, you can clear out of it, go back to your home screen. And then we're going to find our determinant option. So go back to your matrix menu and go over to math. And it should be the very first thing that you see. So click on that. And then go click matrix A. You got it? So we're going to clear out of here. So second mode. Go back to my matrix menu. Go over to math. It is the very first option, which is determinant. And then go back and pick the matrix we just put in there. I used A. And then enter. Make sure you're getting -14. Good. Make sure you're getting -14 for that one. What's up? Okay, so can I do this problem?
Yes.
Yes, we can. So each time I'm this whole determinant A, that's what we just found. That's the -14. Okay. All right. So again, each time I'm looking for a new variable, the JKL, which is our constants, are put into their spots. Look, it's my constants, my Y's, and my Z's. My X's, my constants, my Z's. My X's, my Y's, and my constants. So what we're looking for gets replaced with the constant column. Okay? So let's set up each one of these. We'll do X first. There we go. So X is going to equal the determinant of our constants, which are what? 21, -5, -17. Okay. The coefficients for my Y's, which were -3, 4, and -2. And then the coefficients for my Z's, which were 5, -3, and -1. And we're going to divide that by the -14 we just found. So you have a new determinant defined. Yes. The way they show in the next section is my favorite way. So there's multiple ways to do it. This is just one of them. All right, so find the determinant of that one. Make sure you're getting the number 42. If you are not getting 42, something's up. And don't just write it down because I wrote it down. Make sure you actually type in your calculator and make sure you get the number 42 to get that x is a value of -3. Okay. If that worked, try to set up y. So to find y, your constants are now in the y column. Okay, so our determinant is going to be the coefficients for x, which were -1, 1, and 1. Here's my y, so we're going to use our constants, which were 21, -5, and -17. And then our z's, which are 5, -3, -1. You do that and tell me what you get. Here we go. So z, we have our x's, we have our y's. We're looking for my z's, so that's where our constants come in. So we're finding the determinant now of -1, -3, 21, 1, 4, -5, 1, -2, -17. Try that one. We should be getting a determinant of -84 for that one. So when you divide that by -14, we get a +6. So, how do we write a solution when there's 3 pieces? You just do x, then y, then z.
Why do you have wait?
Mm-hmm.
Is it like a 3 plane?
Yes.
Yeah, I was like, wait, is this a line?
Yes.
Oh, wait, that's how coordinates work. I'm like a micro.
Correct. Yes. So this one has like dimension into it, or depth.
Yeah. Okay.
Length, width, depth for that one. All right. Bless you. All right, guys, here we go. Last one. Last one. We are going to do real life, so it ties it with chemistry. Okay? I know. The molecular mass of a compound is the sum of the atomic masses of the atoms it contains. Okay? The table shows the molecular masses in atomic mass units of 3 compounds. Use a linear system and Cramer's rule to find the atomic masses of bromine, nitrogen, and fluorine. Okay? So, they have given me pieces of their formula, right? We either have Br for bromine, we have N for nitrogen, or an F for fluorine, right? And the little numbers tell us how many of those molecules we have. Okay? Those are your coefficients. Mm-hmm. So my first compound, okay, I'm going to put it over here. No, chemistry and math go together. So our first one, do we agree it has 1 bromine? It has 3 nitrogens, and it has 0 fluorines, and it equals 122? Yes? Do we see where that just came from? It's a 1Br. Okay. Our next one has 1Br again, right? It has no nitrogens. And it has 3 fluorines to equal 137. Because they're not there. And then this one doesn't have any bromines. It has 1 nitrogen, and it has 3 fluorines, and it equals 71. So we need, Noah, to answer your question, we need to put zeros because it needs to maintain a 3 by 3 matrix. Everything in that first column has to represent bromine. So if there was another number in there for nitrogen, that would mess it all up. Our second column is all the nitrogens. Our third column is all the fluorines. So if it's not there, we put a 0 in its spot. Okay, so now we need to find the determinant of the coefficient matrix, which is going to be 1, 1, 0 for my bromines, 3, 0, 1 for the nitrogen, and 0, 3, 3 for the fluorine. So what is that? What is it? Negative 12? Yes, you should be getting negative 12.
You're right, Noah. I'm literally
Yes.
you learned acceptance. Is that always taking it in
Yes. Yep. So now we need to find bromine, nitrogen, and fluorine on their own. Okay? You do one, have someone close by do a different one, and we will bring all of our answers together. Okay? So, see, make you and your neighbor do 2 different ones. What are the units? Okay, so for nitrogen, oh, I don't know. So we did 1, 1. It just says in atomic mass units. So I'm not sure. 122, 137, and 71. And then we had 0, 3, 3. The determinant of that equal to negative 168. So divided by 12, that gives us an atomic mass of 14 for nitrogen. Trying to fit all this on here. And then our fluorine, what do we get for fluorine? 19?
I got 19.
Good, we should get 19 for our mass. Yep, so our setup for this one was 1, 1, 0, 3, 0, 1, 122, 137, and 71. Divided by our determinant of negative 12. The determinant of that 3 by 3 matrix, you should have gotten negative 228 divided by negative 12, which gives us an atomic mass of 19 units for fluorine. So our bromine was 80, our nitrogen was 14, and our fluorine was 19. All right. We good? Yes. Yes.
Actually understand
Good.
this.